Hi students, welcome to Physics for Everyone classes. This is your Satish. In the last video, we have seen the motional EMF in the most general case, which is here you can see integral of V bar cross B bar dot dl bar. If we have the vectors knowledge, we can also say it is a scalar triple product, which means here in this equation the three vectors are being operated. The one is velocity vector, and the second is magnetic field vector, and third is the length of the conductor. By taking the cross of V and V, you will get a new vector, and that vector is multiplied with the length of the conductor by using dot operation. The dot product of two vectors always gives the scalar. Here is the induced EMF, or more generally we can call it as a potential difference across the end of the rod, which is a scalar quantity. Now, here in this section, by using this formula, we need to find the induced EMF for different cases. Let me call it as applications of the concept. Let us start today's class by taking the first application here on the board. Let us see. So here in this application, I taken a semicircular rod. Here you can see PQ, which is the semicircular conductor. Now, which is arranged in the XY plane. There I am taking the reference here, X-axis, Y-axis and Z-axis. This ring, this conductor which is placed in the XY plane. There you can see it is placed on the XY plane. And the magnetic field is set into the board, which means along the negative Z-axis, because you can see Z-axis is outward. So into the board we can take it as negative Z-axis. And this conductor is placed in XY plane and the magnetic field is set into the Z-axis. And this conductor is taking along positive X-axis about its center. You can see this is the center part of the conductor. About this point, this is taking along positive X-axis with some velocity. Now, how much is the induced EMF which is developed across the end of the conductors? How you can calculate? So we have got a formula. You can see V bar cross B bar. V direction is fixed along positive X-axis. B direction is also fixed along negative Z-axis. But the length of the conductor is not uniform here in this case. We cannot directly the entire length of the conductor as dl bar, or the effective length of the conductor. So our first target is to find what is the effective length of this conductor. If we know this, we can easily use this formula to find the induced EMF. So what is our first target? To find what is the effective length of this semicircular conductor. Let us see once. So I am not taking the entire conductor PQ at all. So I taken here a small element. Here you can see AB is a small element. Similarly, CD is the second element and EF is the third element. So let us target a small element AB in this manner. This is a small element AB. When you take a small element, this curvature part appears as a straight line. So that is the case I am taking here the part as a straight line. This is a part of a conductor. Name it as AB. Is it okay? Right. So what is AB? AB is a part of semicircular conductor. And it appears as a straight line because it is it has a small length. Now, this length is divided into two components. For example, you can take this is the one component and here is the second component. So along x-axis, the component is taken as dx, and along y-axis, it is taken along dy. You can see on this small conductor, the direction of V bar cross B bar, again we need to use the cross code. V bar along x-axis, B bar along negative z-axis, then V cross B, you are getting V cross B along the positive axis. So, on this conductor, I am taking V bar cross B bar along the positive axis. We know that the length of the conductor should be along the direction of V bar cross B bar, then only you will get the result. If you see clearly, the elemental length dx, this is dx, which is perpendicular to V bar cross B bar. So because of this element, the induced EMF comes as how much? 0. So no need to take the x component of the length of the conductor whose EMF is coming 0. So let us take the another element dy, which is parallel to V bar cross P bar, the dot product of two vectors, which you will get the result induced EMF. So for the small element AB, we need to consider only the vertical component of length is named as dy. So dy is along the direction of V bar cross B bar. We need to consider that the component of length along the y-axis only. Now let us take the second element which is named as the CD. You can see this part C. This is C and it is D. So which is very much nearer to the center part of the semicircular conductor. It itself is a straight conductor and also acting along the positive y-axis. You can see along the positive y-axis. No need to divide this into components. So directly you can take here on this element the direction of V bar cross B bar is along positive y-axis, and length of this element again named it as dy is also along positive y-axis. We need to consider this elemental part of the semicircular conductor. Similarly, if we consider the element EF, which has been like this, just like a negative slope, and named it as this one is Z and here it is F. Okay? Now, we can divide this element into two components again. One along the x-axis, other is along the y-axis. Named it as this is dx and here it is dy. Again the same thing. V bar cross B bar, the direction is fixed. V bar cross B bar is along positive y-axis. And out of these two smaller elements, dx, which is coming perpendicular to V bar cross B bar, so no need to consider this elemental part. And dy is along the positive axis, which is matching the direction of V bar cross B bar. We need to consider the elemental part dy. So in the same way, if we come across from P to Q, we need to consider only the vertical component of the length of the conductor. If we add all such dy's, this is 1, here it is 2, and here is 3. Like that, if you are adding all the things, you will get the displacement vector. We can call it as the vertical component of the displacement vector joining from initial point to the final point. More generally, we can call it as a line joining from initial point to final point is called as a displacement vector. Here it comes as the effective length of the conductor, which is nothing but the displacement from point P to point Q, irrespective of the direction of the current. Actually, the current is moving along the actual length of the conductor, but we are not taking here the effective length in that direction, because the component of length which is perpendicular to V bar cross B bar, you are getting the answer how much? 0, because the dot product of two perpendicular vectors is always how much? 0. So, the effective length of the conductor LE, which is equal to PQ Vector you can write effectively. Displacement vector, which is nothing but 2 times the radius, because as it is a semicircular, it has got some radius r, and a line joining from P to Q comes as the diameter of that semicircular conductor, nothing but 2 times its radius, 2r. Okay, so we got the effective length. The next question is that in which side you will get the positive polarity and which side is the negative polarity. So please remember always in which direction you will get V bar cross B bar. So V bar cross B bar, you will get some direction. Along the direction towards that point, you always get the positive polarity. So V bar cross B bar is towards P. You can see it is along positive axis, that is towards P. At point P, it is acting towards point P. At point P, you will get the positive charge, higher potential. Therefore, at the another point, which is named as the point Q, there you will get the negative potential or lower potential. So as this rod, which is placed along positive axis, and the magnetic field is set into the board along the negative z axis, if this conductor is taking along positive axis, you will get the positive polarity at the top end, negative polarity at the bottom end. So most questions in the examinations are being asked. The magnetic field is into the board. The conductor is placed vertically inside the magnetic field and it is taking along the positive x-axis. Now, at the top point, always you will get positive and the bottom point you will get always negative. Is it okay? Right. So, if any one of two are changed, then the polarity is also changed. For example, the rod is taking along x-axis. If the magnetic field is set along the positive z-axis out of the board, then the polarities are reversed. At the top, now you will get negative charge. At the bottom, you will get the positive charge. It all depends on in which direction you will get V bar cross B bar. So that is the case. This is the most important point to decide the polarity of the rod. Which side you will get the positive polarity. That is defined by the direction of V bar cross B bar. So in which direction you will get V bar cross B bar, that defines that point comes as the positive polarity. The other point comes as the negative polarity. This is a very conceptual point. So after getting all these things, we got the effective length, we got B and we got L. So directly we can use here E is equal to BLV. What is LA? Effective length. Because as I got the effective length which is along positive y-axis, then directly this formula is being converted into shorter form BLV. So which is equal to how much here in this case be given 20 Tesla, and effective length is 2 times radius. Here is radius is given as 1 meter. You can see radius is 1 meter. So 2 times radius is 2 into 1 into velocity 10 meter per second. You can write here 10, which is equal to 20 into 2, 40, 40 into 10, you will get 400 and the unit for induced EMF is volt. And you got the answer, induced EMF for this application is 400 volt. So here we can see the second application. You can see the magnetic field is taking along the x-axis. How much the magnitude? 10 Tesla. And the length of the conductor PQ of the length is taken as 4 meters along the x-axis. And this rod is taking along the positive y-axis with velocity 5 meters per second. And how much is the induced EMF which is developed across the conductor PQ? So if I take this formula, E is equal to integral of V bar cross B bar dot dl bar. V which is fixed along positive y-axis, B it is along positive x-axis. If you take V cross B, we need to take the direction of V cross B. So this is V and here is B. V cross B. We need to move from V to B like this. V to B. The thumb is acting into the board, which means along negative z-axis. So this z-axis, which is perpendicular to the length of the conductor, because the length of the conductor is set along the x-axis, and V cross B you are getting along the negative z-axis. These two vectors are perpendicular to each other. There you will get the result how much? 0. So there will be no induced EMF will be created across the ends of the rod. How simple it is. So if any two vectors out of 3, if any two vectors which are parallel to each other, they may be equal or unequal. If they are parallel to each other, that is enough to get the result always 0. Induced EMF is 0. Out of 3 vectors, those are V bar, B bar and L bar. Out of 3 vectors, any two vectors, maybe VB or BL or VL, any two, out of 3, any two, if they are parallel to each other, you will get the result is always 0. For example, as I told, it is a scalar triple product. We can write it as E is equal to box of, we can write in terms of vectors in the box. V bar, first vector, second vector is B bar and the third vector is L bar. So directly we can take L bar because it is a uniform rod. So V, B, L, 3 different vectors. We can express B bar in terms of L bar. For example, if I write this one, 10 into 4 divided by 4 Tesla, because 4 and 4 get cancelled, you will get again 10. But how much is the length? 4 meter. So that is equal to, if I leave 4, 10 by 4 I can take it as a constant K, 4K. So what is 4? 4 is length of the conductor, and there you will get B bar, which is equal to some constant K into LE bar. There you can see these two vectors, because we wrote B in terms of length of the conductor, which is given as 4. The 4 is replaced with length of the conductor. Finally, you will get B bar is equal to some constant K into LE bar. So B bar and L bar are parallel to each other. So this you can write it as V bar, B bar as some constant K into LE bar and LE bar. What is LE? Length of, effective length of the conductor. So these two vectors are parallel. And how much? You will get the result. E is equal to 0. Maybe sometimes V and B bar are parallel to each other. There also you will get the induced EMF is 0. Or B and L is parallel to each other. Here in this case, B bar and L bar are parallel to each other. Here in this case, you got the result how much? 0. Or some other case, if you take V bar and L bar, if they are parallel to each other, there also you will get the result how much? 0. So out of 3 vectors, V bar, B bar, L bar, out of 3, if any two are parallel to each other, irrespective of, you can take either you can take same magnitude, same direction, or different magnitude, same direction. That's why we are calling it as, if they are parallel vectors, might be the magnitudes are equal or unequal. So V bar, B bar, or B bar, L bar, or B bar, L bar. If any one is parallel to each other, you will get the result how much? 0. Very important. By looking at the question, we can take the answer induced EMF is equal to 0. The reason is B bar is parallel to L bar. Out of 3, 2 vectors parallel, the result is 0. Okay, you got the answer 0. And there will be no positive polarity, there will be no negative polarity, because there is no potential difference created across the ends of the rod. And if you can see the third application here. So here in this question, the magnetic field is set out of the board. You can see the dot is used. The dot represents the magnetic field is acting out of the board, or we can say along the positive z-axis. And the length of the conductor PQ, whose length is 5 meter, is taking along positive x-axis. This is the x-axis. And this rod is taking in xy plane. This is xy plane with velocity v, which makes an angle theta given 30 degree with the x-axis. And how much is the induced EMF created here in this case? The same thing. First, we need to find the effective length. The effective length is okay because it is not a non-uniform rod. Directly it is given uniform rod. PQ is the effective length. But so V bar is in this direction, B bar is outward. You can see this is V bar direction, B bar is outward. Like this. This is V bar along on the xy plane. This is V bar and B bar is outward. So V bar cross B bar. The thumb, you can see the thumb which is inclined in this direction. So V bar cross B bar direction is going in this way. So the length of the conductor should be perpendicular to this one. So this is, I'm drawing here. This is the direction of, you can see here, this is the direction of V bar cross B bar. Is it okay? This V bar cross B bar is on the xy plane, which is perpendicular to V bar, right? This is perpendicular, this line is perpendicular to V bar. And also perpendicular to B bar. When B bar is out of the board, this line is perpendicular to B bar. So V bar cross B bar is on the xy plane, and which is perpendicular to V bar and which is perpendicular to B bar also. Now we need to take the length of the conductor which is perpendicular to this V bar cross B bar, which means we need to take the length of the conductor along the direction of V bar, which becomes the perpendicular to V bar cross B bar. So very easily we can resolve the length into two components. One along, you can see, one along the velocity vector and other is along the direction of V bar cross B bar. How much is the angle here? 30 degree. This is 30 degree. And this is the length L. We can divide. This comes as L cos 30 degree and this comes as L sin 30 degree. So one of the component of length, which is L sin 30, comes along the direction of V bar cross B bar. That is the effective length which gives us the induced EMF. The other component is there. The other component of length is there, which is L cos 30. That comes along direction of V bar, but whose direction is perpendicular to V bar cross B bar. So the dot product of L cos 30 and V bar cross B bar, how much? 0, because as these two are perpendicular to each other. Now what we can write here, induced EMF is equal to B into component of length along the direction of V bar cross B bar. How much you got? L sin theta, or you can write L sin theta, where theta is 30. At last we can substitute L sin theta into velocity V. Don't use cross, directly you can write V again. So B into L sin theta, which is the component of length along the direction of V bar cross B bar into velocity of the rod. That is equal to, how much B given? 2. Length of the conductor is taken as 5 and sin 30, which is 1 by 2. The velocity magnitude is given 4. So substitute all the values there and 2 get cancelled and 5 into 4 you will get the 20. The answer you are getting 20 volt is the potential difference across the ends of the rod. After getting the value, the question is that which side you will get the positive, which side is the negative polarities. So as I told you, V bar cross B bar direction defines the positive sign. This is the direction of V bar cross B bar. If you see here, the effective length of the conductor, L sin theta is in this direction, L cos theta is in this direction. How you can judge which side? This arrow is tilting, is showing to which side? Is it is Q or P? This is P side, this is Q side. It is tilting towards the Q side, which means that the side Q represents the positive polarity and the side P comes as the negative polarity. So here V bar cross B bar is tilting towards which side? Maybe it is not exactly matching the Q side. It is tilting towards the Q side. It is on the Q side. That side you will get the positive polarity. Other side comes as the negative.